Hello guys, I hope you are doing well. So today we're gonna have optimization problem, and as you can see, I have two positive integers and we call them x and y. What's already given is that the sum of these two integers is 12, which means I already have x plus y equals 12. And they want me to find the product as big as I can. So find the maximum product of the two numbers x and y. And actually I want to use derivatives because it's one application of optimization here. But let's assume just for a little that we don't know anything about derivatives. And still I want to find the maximum product of x and y. Since they both are positive integers and the sum is 12, I can make a table, as you can see here, thinking about all positive integers with sum of 12. So for an example, if I have 1 for x and 11 for y, you will notice that the sum of these two numbers is 12. What about the product? X times y in this case. As you see, 1 times 11 is 11. So the product is 11 in this case. If x equals 2, then y equals 10. Again, the sum is 12. And the product in this case is 20, which is higher than 11, which is much more better. Let's try other numbers. If x equals 3, what number I'm going to add to 3 to get 12? It must be 9. And now see that the product of 3 and 9, I'm going to have 27. My answer is getting better and better. So let's try another number for x, which is 4. 4 multiplied by what number I'm going to have? What should I write here, by the way? As you can see, the sum of these x and y is 12, so I have no choice just to write 8. Now the sum of 4 and 8 is 12, but the product is 32.
So I think 6 and 6 gonna be the biggest.
You're right, good for you. But since I want to cover all numbers, positive numbers I have, I can try 5 first, then I'm gonna try 6 next. If I have 5, I'm going to have 7 for 1, and the product will be 35. And for 6, I must have y also equal to 6. And here, in this case, the product is 36. And exactly as you said, this is the best answer I can get. And after 6, I can have 7, but we already studied this case. Because of symmetry, no need to repeat these numbers again. 7 for x, 8 for x, 9 for x, because I'm going to have the same answer at the end. So clearly from this table, my answer will be 6 for x and 6 for y, and the product I'm looking for is 36. Now, how can I apply derivatives? So let me take a look. I already have this relation between x and y, and I want to maximize the following function. Now I have this function, which is function in terms of x and y, and this function is the product of x and y. And again, I have function of two variables, which is not nice. I want to make it as a function of one variable. So I have to replace x with y, or I can replace y with x. Sure, I'm going to use this relation between x and y. So for an example, I can write y equals 12 minus x. And using this relation, I can write my function again as a function just in terms of x. So here I already have x, and instead of y, I'm going to write 12 minus x. So here is my new function, and I have just one variable, which is x. Let me simplify it for you. My function in terms of x looks like the following: 12x minus x squared. So I won't need this guy anymore, and now I have to find the derivative of this function. And as we know, the derivative of polynomial is given as follows: f prime x equals to the derivative of the first term is just the coefficient 12, and the derivative of the second term is minus 2x. And if I want to find the critical points, I have to solve the following equation: f prime x equal to 0, which means I have to solve the following linear equation: 12 minus 2x equal to 0, which means x equals to 6. But if x equal to 6 and the sum of x and y is 12, it means y also equals to 6. So this is the critical point I'm looking for. And these two values will give me the maximum of my function. If I want to check, any question here?
I want to know, can we draw a graph like based on the 12x minus x squared, like that one? Can we draw a graph?
You mean if I want to write x plus y equals 12, it looks like a line in the space here.
No, I mean that one.
Which one?
F, then x.
F prime x
No,
equal to 0, and here f x equal to this guy.
Yeah,
It looks like a parabola. And this parabola, as you know, it looks down there.
Yeah, so there is something like the mixed
Which we
minus.
call it the vertex of this parabola. Here we can draw it, but also we can solve it without the drawing. Maybe I can draw it for you later. But first, let's check if this value will give me the maximum or not. So let me see how it looks like. Using this table, as x is my variable, and here I have my derivative, and here I have my function. X, as you see above, is positive integer, and the sum of x and y is 12. So x cannot exceed 12, and it cannot equal to 0. Both in this case and this case, my function will equal to 0. Why? Because my function is a product. 0 multiplied by whatever number, I'm going to have 0. And for x equals 12, it means y equal to 0. And again, my product is 0. And in the middle here, I have this critical point, which is 6. This is the point that makes my derivative equal to 0. And let me check my derivative again. My derivative here is 12 minus 2x. 12 minus 2x, when x is less than 0, like for example 5, and you plug 5 here, I'm going to have 12 minus 10, which is 2, it's a positive number. And when I have x bigger than 6, I'm going to have something like 7, for example, or 8, or 9, or 10. I'm going to have 12 minus 20, which is negative number, which means my function is increasing up to this point, and then it's decreasing after this, which means at this point, I'm going to have a maximum. Now, back to your question. My function f looks like a parabola, and this parabola is concave down. So if I want to draw this parabola here, and no need for this table anymore, I have to draw the following function. If x again equals to the following, 12x minus x squared. And now, as you can see, when I plug x equals 6 here, I'm going to have the following. 12 multiplied by x minus 6 squared, which is 6 times 2, I have 2, and here I have 7, minus 36, and here I have 36. Which means my parabola, as I said, which looks down like this point, it has the vertex above, and this point is 6, 36. And this is the highest point I can have in this parabola, which I call it the vertex of this parabola. And now I got my answer. I hope this is clear for you. Thanks for coming.